There are moments in science when the world feels still, as if the universe itself is holding its breath. This was one of those moments. It began quietly, inside a dim control room in western China, where a team of tired astronomers stared at fresh data streaming in from their newest deep space observatory. They expected routine numbers, a predictable light curve from a faint traveler drifting through the solar system. But instead, they saw something else. Something that made every person in the room sit upright. 3I/Atlas, an interstellar object already known for its strange path, was approaching perihelion. Normally, as an object gets closer to the sun, the brightness follows a smooth rise and fall. Dust warms, ice melts, light scatters in soft, natural curves. But this time the curve didn't curve. It jumped. Sharp, sudden, angular. A pulse of light that looked nothing like dust or ice or anything shaped by nature. It was clean, almost geometric, like sunlight bouncing off a sheet of polished metal drifting through space. For a few seconds, no one spoke. The only sound was the soft clicking of keyboards and the faint hum of machines, as if even the equipment sensed something wasn't right. One of the junior analysts zoomed into the data, replaying the spike again and again. "It shouldn't do that," she whispered. And she was right. These pulses weren't soft flares. They were reflections, crisp, timed, almost mechanical in their precision. As the object spun, the brightness didn't shimmer like a comet. It blinked. It snapped. It sent out flashes that looked like signals. The team tried to rationalize it. Dust pockets, ice fractures, rotational wobble. But nothing fit. Every natural explanation fell apart under the hard weight of the numbers. So they pulled the first high-resolution images. And that's when the room changed. On the screen, 3I/Atlas didn't look smooth or chaotic, like a normal comic core. Its edges, blurred by distance but not enough to hide, hinted at something else. Planes, surfaces, angles, as if the object wasn't carved by time, but assembled. You could almost feel the air tighten. An older scientist, with decades of cosmic experience behind him, leaned closer until his breath fogged the glass of the monitor. He'd studied hundreds of comets, asteroids, and wandering interstellar fragments. He'd seen strange things, unusually bright objects, broken fragments, even the wild behavior of Oumuamua. But this was different. The reflection was too perfect, too clean, too rhythmic. Nature may be beautiful, but it rarely builds straight lines, and it never creates a mirror. The team ran more tests. They compared the readings with simulations. They checked the rotation rate, the trajectory, the temperature, even the gravitational tug on nearby particles. Everything screamed the same impossible truth. 3I/Atlas wasn't behaving like a rock. It was behaving like something made, a shape that rotated just right to catch the sun at exact intervals. A body that sent off flashes, as if it were built from panels, not stone. A surface too smooth for cosmic weathering, too reflective for random formation. Still, no one dared say the word. Artificial. It hung in the silence, unspoken but heavy, swirling between the scientists like a quiet storm. Instead, they spoke softly about anomalies and unexpected signatures, but deep down, they all felt the same cold shift in their stomachs. The slow, creeping realization that this discovery wasn't just scientific. It was personal. Because when something from another star system behaves like it has edges or surfaces or intention, the universe suddenly feels smaller, closer, a little more aware, and that awareness cuts deeper than any data point. As the hours passed, more images arrived. Each one brought the same unsettling truth. The pulses weren't random. They followed the same timing, the same orientation, the same impossible geometry. It was like watching a lighthouse turn in the dark. Steady, predictable, almost calm, except this lighthouse was drifting through the solar system, silent and cold. The team finally forwarded the files to Beijing. Within minutes, the images were locked behind secure networks. Researchers were told to remain quiet. The public explanation would focus on dust anomaly behavior. But the people in that room knew the truth. You could hear it in their voices when they whispered to each other in the hallway. You could see it in their faces when they stare at the final process frame, a single bright flare slicing across the image like a blade of white fire. One scientist sat back in his chair and covered his mouth, as if trying to hold a thought inside his body. "What kind of surface reflects like that?" he murmured. "And why is it shaped this way?" A question that felt less like curiosity and more like a warning, because if the reflection wasn't natural, then someone or something engineered it. Or maybe it wasn't meant to be seen at all. Maybe the flashes weren't signals, but scars. Maybe they were remnants of something broken, drifting, forgotten. Or maybe, and this was a fear no one wanted to voice, maybe the reflections weren't an accident at all. Maybe they were intentional. A message sent through silence, a pulse written in light. Outside, the sun continued to burn, indifferent to the mystery unfolding around it. And far out in space, 3i/Atlas kept turning, flashing at impossible reflections into the dark like a cosmic heartbeat. A heartbeat no one could explain. A heartbeat no one was ready for. Yet the question lingered, echoing through every lab that touched the data. If something out there can reflect the sun like a precision-crafted mirror, what exactly is drifting through our solar system? And more importantly, why is it here? There's a strange kind of quiet that comes after discovery you can't explain. A quiet that doesn't feel peaceful, but heavy, like the air knows something you don't. That was the quiet inside the Chinese research facility, the morning the infrared scans arrived. After the impossible reflections from 3i/Atlas, the team hoped that the thermal readings would bring clarity. Something simple, something natural. Ice pockets warming, dust cooling, any normal explanation to pull them back to the familiar ground of physics. But the universe had other plans. The first scan appeared on screen as a soft cloud of colors, reds, blues, greens. But then the software sharpened it, revealing the truth beneath. And suddenly, everyone in the room stopped breathing. Heat was blooming across the object's surface, not like a melting comet, not like sunlight warming rock. It was blooming in patterns, perfect geometric grids, squares of heat igniting in a sequence, then shutting off, then igniting again. A repeating cycle, like an engine test, or a heartbeat made of fire and cold. The lead analyst ran a second scan. Same result, then a third. Still there. The heat wasn't drifting. It wasn't random. It was pulsing. One scientist leaned forward until his forehead almost touched the monitor. His voice cracked when he whispered, "It's counting," because that's what it looked like, a countdown, or a metronome, or a machine waking up after a long sleep. Each thermal square brightened with the same intensity, the same duration, the same spacing, like a grid of lights hidden beneath layers of ice and dust, switching on and off in a calm, steady rhythm. Someone in the back tried to break the tension with a joke, something about solar heating, but his voice trembled and nobody laughed, because they all knew the truth. Nature does not keep perfect time. Natural objects heat unevenly, unpredictably, without symmetry. Temperature doesn't obey geometry. But here, locked beneath the shell of this interstellar traveler, something was obeying it with absolute precision. Another screen lit up with a cooling curve, charting how fast the object lost heat. It dropped too fast, far too fast, like something inside was forcing the surface to chill again, as if regulating its own temperature. Why would it do that? A young researcher asked. No one had an answer. The lead supervisor swallowed hard. Run a pattern analysis. The computer hummed for a long, painful minute. Then it displayed a spike. The grid pulses weren't just timed. They were structured. Every fourth pulse was slightly longer. Every eighth was brighter. Every 16th carried a faint secondary bloom, a whisper heat behind the main flash. In other words, it wasn't a pattern of nature. It was a pattern of purpose, a system, a clock, a cycle repeating with discipline. One scientist, the same veteran who watched the strange reflections the night before, clenched his jaw. His voice was barely above a breath. This is coordination. And that word changed the energy in the room, because coordination meant mechanism. Mechanism meant design. And design meant origin. The debate struck instantly. Some argued it had to be internal chemistry, leftover energy from interstellar radiation, trapped pockets of reactive material. They threw every natural explanation at the thermal map, anything to pull themselves back from the edge of something unimaginable. But the grid kept cycling, heat rising and falling like a calm mechanical breath, a breath that seemed almost patient. By noon, the data had made its way to Beijing, then to a hidden circle of astrophysicists around the world. Soon there were whisper calls at 3 a.m., emails buried under heavy encryption, late-night meetings in dim offices lit only by the glow of screens. Everyone saw the same thing. The heat pulses weren't just rhythmic, they were measured. The cycle was exactly 131.4 seconds from start to finish. Not 131, not 132, 131.4. If the reflection from Chapter 1 felt like a message in light, then this felt like a message in heat. One scientist in Shanghai drew a sketch of the grid on a whiteboard, each square glowing in a calm sequence. When he stepped back, he stared at it for a long time. "It's not random," he said. "It's not chaotic." Then he looked at his colleagues and said the thing nobody wanted to hear. "It's behaving like a system with intent." The room fell still, because intent is a word you don't use lightly in science. Intent implies agency. Agency implies something inside the object knows what it's doing. And once you accept that, even for a moment, the universe feels different. The team began running scenarios. What kind of natural object creates a self-regulating grid? What kind of interstellar fragment pulses like a machine? What kind of ice shell hides something that ticks? Someone suggested a biological explanation, thermal regulation like a living organism. But even life doesn't heat in perfect squares. Nature doesn't carve patterns that straight. Machines do. Machines that have been built, designed, engineered. Still, no one dared use the word artificial in an official report, but you could feel the word hanging in the air, echoing inside everyone's mind like the pulse itself. Late that night, the infrared station near the moon recorded the clearest thermal cycle yet. Bright, perfect, undeniable. The heat grid lit up like a tiny city map, floating in the darkness of space. Bright square, dark square, bright, dark, like a silent heartbeat beneath a frozen shell. As the object rotated, the grid shifted slightly, giving the eerie sense that something inside was adjusting, reacting, maybe even listening. A young astronomer stared at the repeating pattern on her screen. She didn't speak. She didn't move. She just watched the cycle rise and fall and rise again. Then, almost in a whisper, she asked a question that everyone had been avoiding. Could natural object keep time? Her colleague beside her answered quietly. "No," he said, "but something inside it could." His voice shook as he added one more thought. A thought so heavy it seemed to settle into the room like dust. What if something is waking up? The thermal grid pulsed once more. Perfect, steady, certain. And suddenly, the wrong reflection from Chapter 1 didn't feel like an accident anymore. It felt like a hint, a warning, or maybe a signal. Because the more the scientists stared at the grid, the same question kept rising, cold and sharp as ice. If something inside this object is keeping time, what is it counting down to? There are sounds in the universe we were never meant to hear. Most of space is silent, a cold ocean of dust and stone drifting through darkness. But every once in a while, something breaks that silence. Something faint, fragile, almost shy. A whisper crossing millions of miles to reach us. That whisper came from 3 Ice/Atlas. It started as nothing more than static in a narrow band of radio noise, so soft that the giant dishes on Earth never noticed it. The signal fell below the interference of storms, satellites, human technology, too delicate to survive the noise of our busy world. But hidden on the far side of the moon, shielded by thousands of miles of rock, sat a listening station built for silence, a lonely outpost that hears what Earth cannot. Every day, it turns its giant metal ears toward the void, waiting for the universe to speak. And one night, the universe did. What came through wasn't loud. It wasn't dramatic. It was a hum, a murmur, A gentle vibration, barely detectable. But it wasn't random. It carried structure, repetition, a pulse hiding inside the static. The operator on duty, a quiet engineer who'd worked the station for nearly a decade, almost missed it. But something in the pattern made him stop. Something in the rhythm tug at him, like a heartbeat under a blanket. He listened closer, ran a filtration, stripped away the background, and then he heard it clearly, a slow, deep signal, repeating every 19.7 hours. He stared at the waveform glowing on his screen, a soft curve rising and falling with unnatural precision. Not chaos, not nature's clumsy randomness, but something steady, something intentional. He whispered to himself, "This isn't noise." By morning, the data was already in Beijing. By noon, it was in the hands of scientists around the world. And by sunset, the quiet hum of that whisper had become the center of the greatest scientific argument since the dawn of radio astronomy. Some said it was natural, a thermal resonance, internal cracking, a low-frequency echo from the way the object rotated. But most knew better. Natural signals wander. They drift. They slip out of sync. But this one didn't. It was so exact, it could have been carved into time itself. Every 19.7 hours, the frequency peaked. Every 19.7 hours, it dipped, over and over, like a gentle wave lapping against the shore of the ecliptic plane. And it never missed. Not once. One astrophysicist stared at the repeating cycle for hours. When someone finally asked him what he thought, he answered with a voice barely above a breath. "It's broadcasting." Those two words changed everything. Because if an object from another star system was broadcasting, then it wasn't just passing through space. It was speaking, sending, reaching. But reaching what or who? A team in Shanghai isolated the signal's harmonic layers. Beneath the main frequency, they discovered faint secondary waves, tiny ripples hiding inside the ripple. It reminded one researcher of the way old beacons use multiple tones to identify themselves, like a signature, a name, or a call sign. Another team analyzed the directionality, comparing the whisper with the object's rotation. The signal didn't simply radiate outward. It aimed, subtly, carefully. As 3I/Atlas spun, the whisper swept across space like a slow-moving lighthouse beam. A beacon in the dark. Theories exploded. Was it damaged? Searching? Sending distress? Or was this some long-forgotten machine, following a program written before Earth ever formed? Governments demanded secrecy. But in the labs and observatories where the data lived, scientists whispered about something far more unsettling. What if the object wasn't calling out to us? What if it was calling out past us? One senior researcher traced a line of the signal through the ecliptic. He projected its path forward, watching it leave our solar system and continue into the deep black between stars. He followed the trajectory for almost an hour before he finally leaned back, pale and shaken. "It's not targeting Earth," he said softly. "It never was. We're just in the way." That idea changed the emotional tone of the entire investigation. The scientists had started by assuming the signal was a reaction to us, a message meant for humanity, a discovery meant to be found. But now the signal felt older, more distant, less like communication, and more like memory. A repeating whisper meant for somewhere else. Someone else. Maybe someone who never answered. Some researchers tried to decipher the signal. They charted its harmonics, ran it through models, searched it for patterns hidden in the noise. A few even wondered if the grid-like thermal pulses from Chapter 2 were connected, if heat and sound were two halves of the same message. But the deeper they looked, the more unsettling the truth became. The message had no beginning, no end. It didn't rise or fall with emotion or urgency. It simply was. Like something that had been speaking for a long, long time. Long before we discovered it. Long before we existed. And still, the signal continued. Every 19.7 hours. Like a slow breath released into the cosmos. Meanwhile, China's lunar station kept its ears open. Every cycle brought the same whisper, soft and constant. The engineers joked that the signal sounded lonely, like an echo wandering through space for centuries, hoping someone familiar would hear it. But the truth felt heavier, because if the whisper was a call, then someone somewhere had built the caller. And if it wasn't a call, if it was something else, then what kind of object broadcasts with no listener? One night, the operator who first discovered the signal stood alone outside the station, staring up at the stars. Above him, the earth hung in silence. Below him, the moon held its ancient cold. He closed his eyes and listened in his memory to that faint vibration, that slow, patient rhythm drifting through space. "It feels alive," he said finally, "not like an animal, but like a memory trying not to fade." The next morning, the signal strengthened for the first time. Not by much, just enough to show that the source wasn't decaying or failing. It was adjusting, correcting, compensating, as if it knew it was being heard. Or worse, as if it had been waiting. Scientists looked at one another with a fear they didn't dare to say out loud. Because the question was no longer, is this a natural emission? The real question was, if something out there is broadcasting, who or what is listening for the reply? There are moments in science when the mystery stops being about what you're seeing and becomes about what you're not seeing. That's where the world found itself as researchers began dissecting the internal structure of 3 Ice/Atlas, an object that looked like stone on the outside, but behaved like something built on inside. It began with a simple question. What is it made of? To answer that, scientists ran density models, gravitational scans, and rotational analyses. But the deeper they looked, the stranger the truth became. Because inside this wandering fragment from another star, something was missing. Voids, hollows, empty chambers where dense rock or ice should have been. One physicist stared at the scan for nearly 10 minutes before speaking. "These aren't cracks," he said quietly. "They're rooms." At first, the team pushed back, not because they believed he was wrong, but because they were too afraid he might be right. Internal cavities in space objects aren't unheard of, but they don't form like this. Not in perfectly spaced intervals. Not in repeating layers. Not in neat, geometric shapes that looked almost organized. As one researcher put it, it's like the object has a skeleton. And that was only the beginning. When they mapped the reflectivity patterns, the same sharp flashes first seen in Chapter 1, they found something else. The bright spots weren't random. They were evenly spaced across the surface, like mirror tiles embedded in a fractured mosaic. Each one reflected sunlight at the same angle. Each one flickered at the same orientation. Each one existed exactly where a structural support beam should be on a designed object. But this wasn't a machine. It wasn't a craft. It was just a rock. A rock that didn't behave like a rock. One engineer stared at the surface map, shaking his head. "It's symmetrical," he muttered. "Nature doesn't do symmetry this clean." The room agreed with him in silence. And then came the strangest discovery yet. By measuring the gravitational tug the object exerted as it rotated, they discovered its mass wasn't stable. It shifted, not wildly, not enough for the object to break apart, but just enough to create a repeating modulation, like a breath, a rhythm, a steady cycle of recalibration, a mass that adjusted itself. One astrophysicist froze when she saw the data. "This is active," she whispered. No one argued. The modulation happened every few rotations, exactly timed, exactly measured. Something inside was moving, not freely, not randomly, but deliberately. The object was balancing itself, correcting itself, keeping its orientation steady, like a machine. But if it was a machine, where were the engines? The joints? The wiring? The mechanics that made it run? There were no moving parts, no gears, no fuel, no signs of construction or assembly. It was a machine without mechanics. That's what terrified the scientific community most. If this was technology, it wasn't built the way humans build. It didn't use components or electronics or any system we recognized. Whatever intelligence, natural process, or alien physics created this, it operated on principles we didn't understand. One researcher in Beijing said it out loud during a late-night meeting. If this thing was made, then its builders didn't build. They shaped, Silence fell over the room, because shaping meant intention without construction, creation without tools, design without parts. It was like imagining a civilization so advanced that their machines grew, like crystals, like coral, like something alive but not living, a structure with purpose but no anatomy, a device with no moving pieces, no seams, no origin we could trace. The senior analyst spoke next, his voice low and unsteady. How do we explain a machine without mechanics? The question hung in the room like a ghost. A younger scientist offered a theory, one she almost didn't dare say aloud. What if it's not a machine, she began, not the way we define one? What if it's the framework, a shell, a container for something else? A container, a vessel, a housing. Something inside the object had shifted mass. Something had created voids. Something had pulsed heat in broadcast signals and reflected light in perfect intervals. Something was using the structure. And maybe, just maybe, the structure wasn't meant to operate on its own. It was the casing, the outer skin, the body of something older and deeper. One physicist suggested that the voids might hold dormant components, dormant not because they were broken, but because they were hibernating. Another scientist wondered if the internal hollows once held something that was no longer there. Transport? Cargo? Passengers? No one wanted to finish that thought. In a conference call that stretched late into the night, an American astrophysicist asked a question that shifted the entire investigation. What if the builders aren't around anymore? A sharp silence followed, because if the object belonged to a dead civilization, then everything inside it, the pulses, the signals, the mass shifts, were leftovers, echoes, automatic systems still running long after their creators vanished. A ghost ship drifting through the stars. But not everyone agreed. A group in Europe pushed back, pointing to precision of the signals and the thermal pulses. It's too clean, too stable, too active, one of them said. If this is abandoned tech, it shouldn't be self-correcting. And that raised a question even more unsettling. What if it's not abandoned? What if it's waiting? Waiting to be found. Waiting to be activated. Waiting for a signal that never came. Or worse, waiting for a signal that did come. As the debate raged, one researcher in Shanghai pulled up a final simulation, a 3D model of 3I/Atlas. The voids, the reflectivity points, the mass modulation zones, everything layered together. When the system finished rendering, the room fell into a deep, uncomfortable silence, because the model didn't look like a rock. It looked like a blueprint of something deliberate, something engineered, something meant to function, even if they didn't yet know how or why. A machine that wasn't a machine, a structure without builders, a design without a designer they could identify. And that left the world with one haunting question. If this object behaves like technology, but shows no sign of construction, then what kind of intelligence makes machines by shaping reality itself? There are discoveries that change science, and then there are discoveries that change scientists. The mystery of 3I/Atlas had already pushed the world to its limits. Strange reflections, thermal grids, whispers in radio bands, and internal structures that felt more like intention than geology. But now, as data poured in faster than it could be understood, something deeper began to break. Not the object, not the numbers, but us, across the planet. Labs that normally work together like a single organism suddenly found themselves divided. China released new imaging that seemed to confirm artificial symmetry in the object's surface reflectivity. A European team countered with a paper arguing that alien explanations were premature and emotionally biased. Meanwhile, a private American observatory leaked modeling results that showed internal voids arranged like rooms, and the leak set off a firestorm. By the end of the week, the scientific world didn't feel like one community anymore. It felt like two. One side believed the object was simply behaving in ways our models couldn't yet explain. The other believed something extraordinary, something artificial, was drifting through our solar system. The arguments weren't simple disagreements. They were emotional, personal, fierce, because every scientist knew the truth. If this object really was artificial, then everything would have to change. A researcher in Beijing slammed her hand on a table during a late-night debate. "Do you realize what this means?" she said. "If it's artificial, the universe is telling us we're not alone. And maybe we were never first." An older physicist across the room shook his head. "Or maybe we're seeing what we want to see. Humans find patterns in clouds, in shadows, in noise. This could all be coincidence. It should have been a harmless disagreement. But nothing about this object was harmless anymore. Governments wanted answers. Universities wanted credit. The public wanted meaning. And beneath it all, a quiet, unsettling idea crept into the back of everyone's mind. What if 3I/Atlas knows we're watching? What if it's reacting to us? Philosophers had already begun to weigh in, not on the science, but on the impact. They warned that discovery doesn't just reveal the unknown. It redefines the one who discovers. It changes our perception of reality, of humanity, of our fragile place in the universe. One well-known thinker wrote, "When we observe the universe, we think we are the watchers. But what if, in moments like this, the universe watches back?" That question spread across the world like a spark. Television debates, podcasts, online arguments that lasted for days. Some believed the object was studying us, a probe, a scout, a messenger. Others said such ideas were pure fantasy, that we were projecting intelligence onto something that had none. But even the skeptics felt the tension, because the data wouldn't stop. And the more it came in, the less natural the object seemed. In Shanghai, a team found that the thermal pulses shifted slightly after the radio whisper was detected. In Colorado, a team claimed the object subtly corrected its spin after Earth aimed multiple telescopes at it. In Germany, researchers suggested the mass modulation appeared synchronized with external observations. It was as if the object wasn't just being watched. It was responding. One scientist summarized the global anxiety in a single sentence. "If we are observing it, why does it feel like it is observing us?" That idea hit hard, not because it implied danger, but because it implied awareness. Awareness changes a relationship. It changes the stakes. If 3I/Atlas was simply a strange rock, we could study it like any other cosmic body. But if it was something else, something built, something guided, something awake, then every measurement, every scan, every whisper we pulled from it was part of a conversation we never knew we were having. A young astrophysicist from India described it perfectly during a live stream that went viral. Discovery reshapes the discoverer. We're not the same species we were a month ago. We've crossed a line and we can't go back. People listened, because whether they believed in artificial origin or not, everyone could feel the shift, a quiet, heavy awareness settling into human consciousness. A feeling that the world had stepped into a larger story. A story written in starlight long before humans learned to walk. In universities, students whispered about the possibilities. In cafes, strangers debated the meaning of intelligence beyond Earth. In religious centers, leaders offered sermons on humility and cosmic wonder. Everyone felt it. A weight, a presence, the sense that we were no longer simply looking at the universe. We were being introduced to it. But in every conversation, a darker question lingered beneath the wonder. Has the observation already changed us? Had it changed our unity, our confidence, our worldview? Had it changed the way we see ourselves, as explorers, or as children staring through the window at something far older, far wiser? In Beijing, the lead analyst who'd been with the project since the first strange reflection felt that question most deeply. Late at night, when the others left, he would sit alone with the data, watching the signals pulse on his screen. The heat grids, the whispers, the reflections, the mass shifts, all the patterns, all the signs. He didn't know what the object was. He didn't know who, if anyone, built it. But he did know one thing. He no longer felt alone in the universe. Not because he believed the object was alive. Not because he believed it was a machine. But because the mystery itself had changed him, changed his perception, changed his place in the story of humanity. For the first time in his life, he felt watched, not threatened, not judged, just noticed. And that feeling was enough to alter everything. He looked out the window at the dark Beijing skyline and whispered, "If we are being observed, what does that make us now?" It was a question echoing across the world, a question no one could escape, because whether the object was a glitch in our understanding or the first true sign of artificial origin, humanity had already crossed a threshold. And once you cross such a threshold, you can't return to who you were before. Now, a final question remained, waiting like a shadow at the edge of every scientific conversation. If this discovery has changed us, what will the next one do? There's a moment in every story where the sound drops out, and the silence says more than any voice ever could. For months, the world watched 3I/Atlas carve its strange path through our solar system, a visitor from the dark between stars. We measured its heat. We tracked its signals. We argued about its structure, its purpose, its origin, but nothing prepared anyone for how the story would end. Not with a message, not with a revelation, but with a silence so absolute it felt intentional. It began as 3I/Atlas made its final approach around the sun. The object had always behaved strangely, but now it moved with grace that felt almost deliberate. Steady, smooth, unhindered by the fiery gravity well beneath it. Dozens of telescopes locked onto it. China's lunar station recorded its faint whisper, still cycling every 19.7 hours. Thermal grids continued to pulse their quiet rhythm. Everything was normal, or as normal as anything about this object could be. Then came perihelion, the closest point, the moment when the sun swallowed the object's silhouette in white fire. For several hours, no one could see anything, not because the object vanished, but because the sun's glare drowned it out. Astronomers waited breath-tight, expecting the familiar signal to return on schedule. But when 19 hours passed, then 20, then 22, nothing came back. The whisper, the faint, rhythmic pulse that it carried across the ecliptic, was gone, not weakened, not warped by solar interference. Gone. At first, scientists assumed it was temporary. Solar storms, light pressure, thermal noise. There were plenty of reasons why the signal might dip. But deep down, every researcher felt the same cold truth rising. This wasn't fading. This was ending. And then, as 3I/Atlas reappeared on the far side of the sun, the world saw the final image. Captured by a solar observation array in China, the frame showed the object emerging from the sun's edge, small, distant, barely more than a glowing speck. But in that same instant, something else happened. A flash. Perfectly symmetrical. Perfectly timed. A single, sharp burst of light from the object's surface. It looked nothing like the irregular reflection seen before. This wasn't pulse. This wasn't a thermal bloom. This wasn't noise. It was the signal. Clear, precise, intentional. And then, after that flash, 3I/Atlas continued drifting out of the solar system, silent as a stone. The thermal grids went dark. The mass modulation vanished. The internal pulses stopped. Every sign of activity, every anomaly, every whisper simply ceased. The object had switched off. A lead scientist in Beijing stared at the last image for hours. He zoomed in until the pixels blurred, trying to find meaning in that final flash. Beside him, a colleague whispered, "Was that a goodbye?" Another voice answered, quiet and shaking, or a door closing. Because that's what it felt like. Not an error, not a malfunction, a decision, as if the object had finished whatever it came here to do, as if our star was only a checkpoint, a place to adjust, to update, to awaken, or to transmit one final message before disappearing back into the deep. And now, the silence left behind was heavier than any signal ever could be. Across the world, scientists debated what it meant. Was the object damaged by the sun? Did its systems overload? Did we trigger something by observing it so closely? Or did it simply choose to stop? Some researchers believe the flash was a final communication, not to us, but to something beyond our reach. A signal aimed not at Earth, but at the dark corridor between stars. A confirmation, a handshake, a release. Others fear the opposite, that the flash was a shut-off, a closure, a final act of sealing itself away from us, a message that we were not ready, or not the ones it came for. Philosophers took it further. One wrote, "The universe spoke. We listened, and then it closed its mouth." Another argued that the silence was the answer, that whatever intelligence shaped this object wasn't interested in dialogue. Not yet, maybe not ever. But beneath every debate was a deeper, quieter fear. What if we weren't meant to see the flash at all? What if we witnessed something we were never meant to understand? Late one night, the original lunar station operator, the man who first heard the Whisper 3 I/Atlas, replayed the final data sequence again and again. He watched the object slip behind the sun. He watched the whisper stop. And then he watched the flash. He didn't see communication. He didn't see disappearance. He saw intent. Something about that last symmetry felt too clean, too deliberate to be an accident. It reminded him of a light turning off in a distant house. A subtle, quiet gesture that meant the occupant was leaving or hiding. He sat there in the dim glow of the control panel and whispered. What did we see? No one answered. Then he asked a question that had haunted every scientist since the silence began. What saw us? Because the truth felt impossible to ignore, the object had reacted. Its signals had shifted. Its pulses had changed. Its behavior aligned with our observations. It wasn't just moving through space. It was aware. Maybe aware of us. Maybe aware of something else. But whatever awareness it had, it took with it into the dark, leaving only the echo of a single flash behind. As the object drifted farther away, beyond the reach of our best instruments, the world felt a strange mixture of relief and loss. The sky looked the same, but humanity didn't. Because once you meet the unknown, truly meet it, you don't go back to who you were. Astronomers still point their instruments at the path 3 I/Atlas traveled, hoping for one more whisper, one more pulse, one more sign. But the silence persists. And now the question hangs over us like a shadow at the edge of the cosmos. What waits for us out there? In the dark places where our signals can't reach, and where something ancient just turned its face away.